right, so the first thing that we're going to do is we're going to go over the pop quiz from yesterday. Tomorrow you have open notes quiz over synthesis and decomposition reactions. After that, the next quiz that you have on Monday, which is single replacement, and what we're learning today will not be open notes. You can, no, this is your paper just to correct and make your own notes on. But there, if you want a red pen, I should have some. All right, let me find it in here. All righty, so on our first one here, lithium plus oxygen, and these were only over decomposition or synthesis reactions. So lithium plus oxygen, what are those going to come together to form? I'm sorry? For the product. So you should have been able to recognize that this was a synthesis reaction, because if it was a decomposition reaction, I wouldn't have had two reactants.
I got Li2.
Perfect. So lithium is Li. Oxygen by itself is diatomic. So you should have recognized that if you went back to your composition or synthesis notes, that this was rule number 1. Metal plus non-metal comes together to form an ionic compound. So you should have ended up with the formula Li2O. And the reason that is because if you look at your charges, lithium is a +1, oxide is a -2. And this is a place a lot of people are having trouble with. They're just putting together compounds, elements to form a compound. They're not checking their charges. So that's why the lithium had to have a subscript of 2. So then my positives and negatives would be equal to each other. And then you needed to do some balancing. And for some reason, this was a hard one for some people to balance. They kind of recognized that you needed to put a 2 in front of here because I needed 2 oxygen. But then a lot of people put a 2 in front of the lithium also, which was not balanced. What did I need in front of the lithium? A 4. All right, number 2, same thing. It has to be a synthesis reaction. It cannot be a decomposition. So you should have still been on your page in your notes looking synthesis. So if you did that, what rule would this have followed under your synthesis reactions? 4, perfect. And 4 says a metallic oxide, which is what I have here, plus water is going to form a metallic hydroxide. So we had barium oxide plus water is going to come together to form a metallic hydroxide. The metal in my case is barium, and hydroxide is OH, and I would have had to put a 2 right here. And once again, the reason for that is barium is a +2, hydroxide's a -1. So now the hydroxide needed the subscript. And did this one need any balancing? No, this one was actually already balanced for you. All right, so there was 2 syntheses, and the next 2 were what kind of reactions? Decomposition reactions. Move these up a little bit. Oh, didn't mean to do that. All right, so first of all, let's write our formula for aluminum chlorate before we start solving them. Aluminum's a +3, Chlorate's a -1. So when I wrote that formula, it should be Al, and then the chlorate is ClO3. That's just straight off your ion sheet. And what subscript does it need? A 3. So there were quite a few people that didn't do that correctly. And now we're going to go to our decomposition rules. So which one would this one follow? Number 5, perfect. And number 5 says an aluminum chlorate decomposes into, not an aluminum, a metal chlorate decomposes into a metal chloride. So my metal in this case is aluminum. So aluminum chloride plus oxygen. And oxygen by itself is diatomic. So I still have some people forgetting that also, and that really does mess you up. Once again, this formula, when I put a metal and a non-metal, I formed an ionic compound, so I have to check the charges. Aluminum is a +3, chloride is a -1, just straight off my ion sheet, so that's why I had to put a 3 here. All right, and then this one could have been, this one was a little difficult, I thought, to balance. Because if you looked here, you have 9 oxygen. And over here with my oxygen, I have that too. So this is always going to be an even number on my product side. So what's that little trick that we do? Anybody remember? If I need to get an odd number even? Multiply it by 2, exactly. So that's what I'm going to do, and I'm going to see if it works out. So now I have 2 aluminum. So I'm going to put my 2 in front of here. That changed my chlorine. 3 times 2 is 6. But I'm still good because my chlorine is here. I have 3 times 2 is 6. So now how many oxygen do I have? 3 times 3 is 9, times 2 is 18. So I need a 9 in front of here. And today when we're doing our combustion reactions, they're real easy as far as writing the products. They can be a little bit difficult to balance. So don't forget this little thing. If you get to some odd number and you need it to be even, don't forget that this little rule. It'll help you out. All right. And then my last one, I gave you the formula. So I had nickel hydroxide. So that's a decomposition reaction. I'm starting just with one reactant. So which rule does this follow? 7, did you say? Yes, ma'am. Thank you, whoever said that back there. Sorry. 7, that's my metal hydroxide decomposes into a metal oxide plus water. So, I mean, I'm not going to lie to y'all. I don't have a lot of these things memorized, even though I teach it, but I forget it by the next year. So that's why you've got to use this to help you out. This is what you use, these rules. They're the things that are going to help you. So as far as writing this formula right here, you needed to realize that this was a +2 nickel. And the reason that is hydroxide's a -1. I have 2 of them. So that means for me only to have 1 atom of nickel, it would have to be the +2. So when I got over here to write this formula, nickel's a +2, oxide's a -2. So that's why I did not need any subscripts there. Remember these charges like this that you're getting on off the ion sheet, you may be writing them here. You might be kind of scratch working them here, but they should not. If you do this, then that makes it wrong. They are never part of the formulas. So once we did all that, did I need to do anything to balance it? No, it was already balanced. 2 hydrogen, 2 oxygen, and 1 nickel. All righty. So tomorrow, The quiz will be pretty similar to this. Like I said, this went in as a daily grade. It was not a quiz grade, so it does not get averaged whenever all the quizzes are averaged for a test grade. It's not part of that. It's just a regular daily grade. And you will have a time restriction tomorrow. So if you still haven't done any practice yet, I would suggest you do that a little bit before we try to quiz tomorrow. All right, anybody have any questions over any of those? All right, we're going to move on to combustion reactions. You actually don't need even need your ion sheet for these today. All right. We're going to skip double replacement until next week because those are they're definitely the most difficult, not probably. They definitely are the most difficult. All right, so we're looking at combustion reactions, and we're specifically looking at combustion reactions of a hydrocarbon. So when oxygen reacts with another substance, usually an hydrocarbon or an alcohol, and an alcohol just means it has an OH group added to it. So one time we did on the warm-up, we did one that was pretty tough to balance. We had to subtract out how many oxygen we have. That was an example of an alcohol. It has carbon, hydrogen, and then an OH group added to it. And it releases energy, usually as heat or light. Sometimes that energy is gathered and used for things, because this is where our hydrocarbon fuels fall in. And a hydrocarbon is any compound containing carbon and hydrogen. Although some of ours will be alcohol, so that's when the oxygen gets thrown in. But whether it's an alcohol or it's just a straight hydrocarbon, your products and the only products you have will be CO2 and H2O. So when you start doing your practice today, your products on every single one are CO2 plus H2O, CO2 plus H2O. You don't even have to look at your ion sheet to see if you're writing it correctly. The hints for balancing these equations: balance your carbon first, then your hydrogen, and leave your oxygen to the last. We've done a few of these, and I think we've done them in that order. And it kind of makes it a little bit easier. All right. So let's look at those real quick. A few examples of that. A little bit bigger, I can't see. All right. So on my first one, I have C3H8 plus oxygen. So a hydrocarbon plus oxygen is going to give me CO2 plus H2O. There are other combustion reactions where you have oxygen as a reactant, but not with the hydrocarbon. That's not what we're talking about. We're doing specifically combustion reactions of hydrocarbons. Josh, you got to take your headphones off for me, please, sir. Thank you. As we're specifically doing that. So that means you're always going to get CO2 plus H2O. So once you've done that, then we're going to balance it. We're going to balance our carbons first. So I have 3 carbons. I'm going to put a 3 here. Then we're going to balance our hydrogens, 8. So I'm going to put a 4 in front of my water. Now I'm going to see how many total oxygen I have, and I'm going to really hope it's an even number, because that's when they're very nice and even. So remember, you're going to be gathering your oxygens from 2 places. 3 times 2, I have 6 here. And then here with the water, I have another 4. So that gives me a total of 10. Nice even number. Split that in half. And what am I going to put in front of my oxygen? 5. So when you're dealing only with the hydrocarbon, no oxygen, and you can get a nice even number of oxygen, they're really easy. When it's not an even number, that's when they get a little bit harder. All right, on the next one, you can see I have a hydrocarbon, and then I also have that oxygen group on that. So that usually requires a little bit more work. It's still going to give me CO2 plus H2O. I'm still going to do the same thing. I'm going to start with my carbon, which is 3. Hydrogen, I have 7 plus another 1 here, so 8. So that means I'm going to put 4 here. Now for my oxygen, I have 3 times 2 is 6 plus another 4, which seems like a good thing because it's a nice even number, but you got to remember you have that one little oxygen hanging around right there. I can't, don't write this because I'm going to have to erase it. I can't put a 5 there because if I did, I say 5 times 2 is 10 plus another 1 is 11. So that doesn't work. So if you remember from when that we did that on our journal, I have 1 oxygen. I'm going to subtract that. And that means I need 9 oxygen from that O2. That's not going to happen. So our little trick is we take our coefficients that we have and we multiply them by 2. So 1 times 2 is 2. You can leave the oxygen alone because that's the one that you're messing with. 3 times 2 gives me 6. 4 times 2 gives me 8. And now I'm going to regroup. For my carbon, 2 times 3, I have 6, and I have 6 here, so that's good. For my hydrogen, 7 times 2 is 14, plus another 2 is 16. So I'm good with that. Now let's see what we got with our oxygen over here. 6 times 2 is 12, plus another 8 equals 20. I have 2 in this alcohol, and remember, you don't want to be messing with that coefficient because it messes everything up. I have 2 with this alcohol. I'm going to subtract that 2 out, which means I need a place for 18 to go. So now, is that doable? What do I need to put in front of my oxygen? A 9, and then it'll get balanced. So some of them you got to play around with those kind of little tricks. And as you start doing more, you may even kind of recognize as you start to be balancing it that you're going to have to do that little thing where you double it. All right, I have one more. I'm going to have y'all write in and we're going to look at. Does anybody have any questions on that one where any of those numbers came from?
So,
Yes, ma'am.
like how it has like the little liquid thing.
Mhm.
So it doesn't matter how the base is. It's always CO2 plus H2.
On this, on the, yes, exactly. And you can put H2O plus CO2. It doesn't matter the order, but yes, no matter how it looks at the beginning as far as the hydrocarbon goes, it's always going to be those same 2 products. All right, let's see. I'm going to move this up a little bit, maybe where I have some space. Oh, maybe after I hit this. Get y'all to just write one more example in. All right, we're going to start with, or maybe I'll just let y'all try it here. That'll be better. C2H6 plus O2. All right, y'all give that one a try, please. All right. What did anybody have coefficients for me? What goes in front of this one? I think it's going to be a 2, well, a total of 4, but 2, yeah. And what in front of my oxygen?
7.
I think we ended up with a 5, but well, I can work back through it. Did y'all get a 5? 7? Oh, let me change that. Then I definitely am going to have to work back through it. Maybe I can't count any longer. And so what'd you get in front of your CO2? Oh, man. Didn't get that at all. I need to redo mine. And what'd you get in front of your water?
6.
Okay. Whew. Somehow I got 2, 5, 2, 6. So, oh, well, that doesn't make any sense just to start off with on my carbon. Okay. So let's see if we're good. We had to do that little trick. So we got 4 carbon, right? 12. Yep. And then 4 times 2 is 8 plus not perfect. That's it. That's a great. Let me change mine. Great balance. So you had to do that little trick. All right. All right. So your practice is all, one more thing. Those these are common hydrocarbons, and you do need to memorize those. You will not see them. This is not on your quiz tomorrow, just like single replacement is not on it. But when you have your quiz on Monday, it will not be open notes. And for some of them, just like you'll see on your practice, you'll just be given the name, not the formula. So those are the ones that you need to memorize for that. There's a type of chemistry that's called organic chemistry that is just over compounds that contain carbon. Many of y'all will probably have to take it when you go to college, especially if you're going into any kind of medical field and even some of your engineering. So these you will see on Monday. So you have the weekend to look at those and to get them memorized. All right, y'all got a little bit of time to do some of your practice. You'll see as you go along, it gets a little bit harder, especially the last, I think 3 or 4 have some oxygens thrown in that make them a little bit harder. And I do have tutorials today after school.